So yesterday we focused on how we can write the scale factor as a percent and vice versa, but today we are going to practice how to fluently find the scale factor no matter what the original or new image is. So let's go ahead and take a look. This problem below says to use the two drawings below to complete the chart. Calculate the first row from drawing 1 to drawing 2 only. So I'm looking at this picture and I see that we have two rectangles, drawing 1 and then drawing 2. The question wants us to go from drawing 1 to drawing 2. So I'm just going to draw an arrow here. So go ahead and draw these two rectangles on your paper. Let me zoom in so we can see the dimensions clearly. And so the first thing, if drawing 2 is a scale drawing of drawing 1, would this be a reduction or an enlargement? And how would we know? Well, I see that if we're going from drawing 1 to drawing 2, it is getting bigger. Therefore, it is an enlargement. So go ahead and label this on your notes as well. And so we know that because drawing 1 is the original and drawing 2 is the new, right? That's the scale drawing based off of the original. Therefore, to find the scale factor, we need to write our ratio as new over original. So let's go ahead and write our ratio. We've been writing this down several times already. New over original. So now we can go ahead and put these two tables into, or find two scale factors for these two boxes in our table. Then we'll later write it as a percent and then again confirm if it is actually an enlargement like we thought it was. Okay, so the first part is finding the quotient, right, that ratio of corresponding horizontal distances. So remember, horizontal is from left to right, like the horizon. So go ahead and add that to your paper, horizon, left to right. So we need to look at what values we have that are horizontal, which are 2.45 and 3.92. Therefore, if we are writing it as new over original, we would write 3.92 over 2.45. And so I don't have room to divide here, so I'm going to zoom back out so we can have some space. And I know using bow tie, 2.45 goes on the outside and 3.92 goes on the inside. I also know that we need to move the decimal over 2 places to the right and therefore 2 places in the right inside, which leads us to 245 going into 392. All right, drawing our seats. 245 goes into 392 one time. So when we subtract and borrow, I get 7 for 147. So because there's more, I need to add my decimal and my 0. Bring down the 0. And 245 goes into 1,470. Let's do our best guess. 200 goes into 1,400 about 7 times. And let's see how far off we are. 14, 17. So it's too much. Let's go down then let's go down by 5. 25, 20, 22, 10, 12, and that's 1225. And actually, I think I just barely missed it. So if I do 245 times 6, sure enough, I would have got it right there at the beginning. So it was 1.6. So that is our scale factor, 1.6. And so we know that we can put this into our equation. Remember, our equation is y equals kx because scale factor is also known as k, or the constant of proportionality. So make sure this is written as well. So I can write this as y equals 1.6x. Perfect. So now we're going to do the same thing here for the vertical distance. So let's make sure that we write vertical. Let me zoom in again. Is up and down, vertical, up and down. And so our ratio of these vertical measurements, let me put a box around them, is 1.5 and 2.4. Remember, it is new over original. So it is 2.4 and 1.5. And I know that we could go ahead and divide and move the decimal points over and do all of that great jazz. But due to time, I'm going to just divide with my handy dandy calculator. And we also get 1.6 as our scale factor. Now we know to easily change that to a percent for this box, we use Dr. P to move it over 2 places to the right. So therefore we move it 2 places and fill with a 0. So our scale factor is 160%. So is this a reduction or an enlargement? Confirmation, it is an enlargement, and we know that because the percentage is more than 100%, right? We saw it visually, and now we confirmed it mathematically. So now they want us to do the same thing, but now going the opposite direction from drawing 2 to drawing 1. So I'm going to keep what I have already. Well, let's go ahead and take a snapshot of this, make sure it's in our notes, because now I'm going to erase what's on my visual so that we can now go from drawing 2 to drawing 1. We're going to keep everything that we have on the side and in the box, but now we're going this direction. And so what can we predict is going to happen for the second row? What do we think is happening when we look at it visually from drawing 2 to drawing 1? Well, it appears to be getting smaller, and we know that's called a reduction. And so we think that because it physically looks smaller than the original, let's see if we mathematically determine that it is. So we're going to find the scale factors of the horizontal distances. But now this is the new image, and this is where we started. This is the original. So when we write new over original, it's going to be 2.45 over 3.92. And once more, we can divide. We can move the decimal point over. And so with our time, I'm going to go ahead and divide it out in my calculator. And I get that the scale factor is 0.625. So I can write our equation as y equals 0.25x. So far we're on the right track because I see that this number is actually less than 1. And I know that when scale factors are less than 1, it ends up being a reduction. So we're on the right track. Now we need to do the scale factor of the vertical distances, which I see is 1.5 over 2.4. And once I divide 1.5 by 2.4, I see that it is the exact same scale factor. And so I can write that as the equation, okay? And now with that decimal, we move it over 2 places to the right using Dr. P. And let's see what we get as a percentage. We get 62.5%. So were we correct in our prediction? Yes, we are. It is a reduction. And we know that because the scale factor is less than 1 and the percentage is less than 100%. So one more stamp as I zoom out so that we can make sure we have all of this lovely notes. Drawing 1 is a reduction to drawing 2 because the corresponding lengths in drawing 1 are smaller than the corresponding lengths in drawing 2. So we know that the scale factor is a reduction when it is less than 1 or 100%. So less than 1 or 100%. And an enlargement, we know that this above problem was an enlargement because the corresponding lengths in drawing 2 was larger than the corresponding lengths in drawing 1, and the scale factor was greater than 1 or 100%. So let's make sure to write those in our notes because we're going to see some more examples and practice this fluency.